So how do we integrate the natural log of x? We're going to derive a formula that you can memorize or just rederive, but it comes from using integration by parts. So as you look at this problem, the natural log of x dx, you're saying, I don't see a product, I don't see two things. Well, you kind of do. It really is the natural log of x multiplied by dx. There really is that product. And so using that mnemonic I late, I is inverse trig functions, L are logarithms, that's all we have. So I'm going to let u equal to the natural log of x, and the only thing I've got left is dx. Okay, so I need the derivative, and we know how to take the derivative of the natural log of x. That's 1 over x dx. And then remember, we're integrating here. The integral of dx is just x, and yes, plus c. So if we have the integral of the natural log of x dx, remember it's u times v, so we're going to have x times the natural log of x minus the integral of v du. So that's going to be x multiplied by 1 over x dx. So doing some simplification, of course that's just 1 dx. And then we know how to integrate that. That's just x. And here's where we need to put that plus c. So that is how we integrate the natural log of x. Really pretty easy when you're using integration by parts. Now let's look at this problem. We have the integral of 4x secant squared 2x dx. U substitution just doesn't get us anywhere, mainly because of that extra x. So again, we should look at it as a product, meaning using the integration by parts. So going back to our mnemonic of what should I let u equal to. I is inverse trig functions, I don't have any. L logarithms, don't have any. A algebraic expressions, that's the things with x or x squares, and yes I do. I have 4x. So I'm going to let u equal to 4x. That means dv is everything else in the problem. I would like for you to pause the video and try to do this problem by yourself, and then if you get stuck or when you're done, continue the video and see if we match. Alright, so let's just check. So we have u, so it means I have to take the derivative. If I have dv, I have to do v, which is the integral. How do you integrate secant squared? Well, it's the tangent of the same angle, but we have to have that derivative of that in that integral, so I have to offset it by the 1/2. This is why it's so important for you to really know your basic integration techniques, like u substitution, all your trig rules, so you're not having to sit there and think of what is the integral of secant squared? How did you get that 1/2? Those should be fairly quick by now. So let's proceed. So we have our integral, our original problem, by parts. It says u times v, so I'm going to multiply those together. So 1/2 times 4 is 2, and then I have an x, tangent of 2x. Then it says minus v du. So again, 1/2 times 4, I'm going to put that 2 on the outside, and I have the tangent of 2x dx. So my question is do we know how to integrate the tangent of 2x? Yes, we do. Yes, we should. So remember, we have to take into account that 2 right there, so be careful. So we have this is equal to 2x times the tangent of 2x, then minus this 2 because of there, times 1/2 because of this. And then, how did you memorize to integrate the tangent? You may have memorized it as the positive natural log of secant, or the negative natural log of cosine. Either one is okay. I'm going to use the positive natural log of the absolute value of my secant function, and of course putting that constant. So just writing this out a little bit neater. So we have minus just the natural log of the secant of 2x plus c, and yes, you need to put absolute values around that. So here are two more examples of how to use the product rule. Most importantly here is, in order to integrate the natural log, you have to know the product rule, or you now need to memorize what it equals to. So we've seen some examples that use the natural log. We used our algebraic functions, but we haven't seen anywhere we used our trig functions or our inverse trig functions. So let's look at this problem. We have 4, which is just a constant, times the arc cosine of x dx. Again, not really much of a product happening here. I really don't see two functions being multiplied. So one of them must be dx. Well, that kind of forces you that this has got to be equal to u. And that really, again, matches our mnemonic where I stands for our inverse trig function. So that's what I'm going to let u equal to. Now again, I'm just going to carry that 4 with it. You can put it on the outside, but sometimes when I just put it on the outside of the integral, I forget about it later. So here I'm going to put that u is equal to 4 times the arc cosine of x, and that means dx is equal to dv. I have to take the derivative. So that means I have to remember how to take the derivative of the inverse cosine or the arc cosine. Again, we need to know our basic rules. So the constant, and it's negative over the square root of 1 minus that squared dx. Go back to your formula sheet that you have to have in your brain. Okay, so here, actually I kind of wrote it backwards, sorry about that. So usually I've been writing it as dv equals what's left over. So solving for v is equal to x, and again we're putting that plus c at the end. So we have our problem, 4 times the arc cosine of x dx equals u times v. So 4x arc cosine of x minus v du. So since I have that minus and this minus, I'm going to make that plus 4x over the square root of 1 minus x squared dx. Well, can I integrate this? Yes, I can. Okay, so if I look at this as x times 1 minus x squared to the negative 1/2 power, I could make a substitution. I really don't want to use u again, so I think let's say w is equal to in this part. So my derivative would be here, and lo and behold, I have that. So what that becomes is negative 1/2 w to the negative 1/2 power. How do you integrate that? Well, we add 1 to the power, and we divide by that or multiply by the reciprocal. So we have 4x arc cosine of x. Then I have this minus sign because of my integral. So I have minus 4 times my w, which was 1 minus x squared to the 1/2 power, which I could write it as a 1/2 power, but I think I'm going to go ahead and write it as a square root, plus c. So again, really have to know that substitution, all those constants, my derivative rules. Let's look at this next example. Hopefully by now you're seeing the products, you're thinking about that mnemonic, ILATE, inverse trig, natural log, algebra comes before the trig. Now I will say again, that's not a rule, it's just a huge suggestion. So I'm going to let u equal to x squared. I'm going to let dv equal to the sine x dx. And again, anytime during the video, pause, work them out on your own, then come back, see if we match. So we need to take the derivative, and I need to integrate. Now, how do we integrate the sine? Yes, it's negative cosine of x. Okay, so by parts, I would have x squared sine x dx equals u times v, so that's going to be minus x squared cosine x minus the product of those, so I have a minus, so that's going to become plus 2x cosine x dx. Do I know how to integrate this? No, not directly. I have to use by parts again. It's still a product. Now this is where you want to be really careful. If you let your u equal to an algebraic expression the first time, if you have to do it again, you want to let u equal to that algebraic expression the second time. If you switch it up, you're just going to go back in really big circles. All right, so hopefully you know I'm just going to use u and v again. It's going to stand for something different. So on this one, I'm going to let u equal to 2x, dv equal to the cosine of x dx, taking the derivative, using the integral. Okay, so I want to take all of this, that was my original problem. This is still okay, so that's minus x squared cosine x. Now I have this, so that is u times v, so I have plus 2x sine of x minus v du. So again, I'm going to pull out the constant. Now, do I finally have an integral that I can integrate? Yes, I do. Making sure I don't forget any parts of my answer. Okay, so the integral of sine, just did that, is negative cosine. So with that negative, that's going to be plus 2 times the cosine of x. And let's make sure we put that plus c.